Hey there, amazing friends! I warmly invite you to join me on this exciting journey by subscribing to my channel, liking, commenting, and sharing my videos. Every like, comment, and share brings us closer together and fuels my passion to create more great content. Your support truly makes all the difference. Thank you for being the heart of this community. Doomsday devices or time gates, exploring the possibility that black hole colliders could warp our future. In a secluded research lab perched on the edge of a coastal plateau, a group of theoretical physicists and engineers gather around an array of glimmering machinery. The main apparatus, nicknamed the Singularity Maker, stands at the heart of the complex, a giant circular collider with magnets that hum faintly, waiting to steer particles at unthinkable speeds. Officially, their mission is to probe the secrets of subatomic matter and the nature of the universe. But rumors swirl that their ambitions are bigger, bordering on the edges of science fiction. An attempt to create microscopic black holes, harness them, and perhaps, just perhaps, reach the boundaries of time itself. To the general public, the question arises: are these colliders potential doomsday devices that risk annihilating the planet? Or might they be the fabled time gates that open new epochs in human exploration? The tension between these two narratives defines our era, a swirl of scientific rigor clashing with existential dread, underscored by the mysteries of quantum mechanics and cosmic phenomena. This exploration delves into how these advanced colliders function, why some fear they could destroy the world, and what leads certain thinkers to propose they might manipulate or warp our future in ways beyond imagining. The impetus for these experiments dates back decades, spurred by the success of projects like the Large Hadron Collider, LHC, which discovered fundamental particles such as the Higgs boson. Motivated by those breakthroughs, the scientific community dared to dream bigger. If smashing protons at energies in the multi-TeV range uncovered crucial truths about mass and symmetry, then even higher energies might pierce deeper secrets. A next-generation collider could surpass all previous scales, venturing into realms where micro-black holes could theoretically form. The notion of micro-black holes is not unsubstantiated science fiction. Some branches of string theory or extra-dimensional hypotheses suggest that at extremely high energy densities, black holes might spontaneously coalesce for brief instants. The matter of whether such phenomena are physically realizable in a collider on Earth remains unsettled. But as soon as the possibility was raised, sensational headlines about man-made black holes devouring the planet began cropping up, igniting public anxiety. Many seasoned physicists tried to reassure the public that any black holes produced would be minuscule and ephemeral, evaporating almost instantly via Hawking radiation. They pointed out that cosmic rays striking Earth at higher energies than collider beams have not triggered planetary destruction, thus, the colliders are presumably safe. Official safety reviews consistently concluded that black hole production, if it occurs, would be harmless. Despite these assurances, pockets of fear persist. They revolve around the notion that if, in some obscure corner of theoretical space, black holes produced in a collider fail to evaporate quickly or become stable, they might sink to Earth's core and devour the planet from within. Though mainstream science deems this scenario practically impossible, the worry never fully dissipates. And so, these advanced colliders exist in a liminal zone, heralded as gateways to a new physics revolution by many, approached with dread by others who recall cautionary tales of doomsday experiments. As if those concerns weren't dramatic enough, a separate and perhaps even more outlandish rumor began to surface in certain theoretical circles and fringe websites. According to this speculation, a sufficiently advanced collider might produce not just black holes, but distortions in the fabric of spacetime. It's one thing to suspect ephemeral micro-singularities, It's another to propose that they could open pathways through time. But in the hallowed halls of speculative physics, there exist solutions to Einstein's field equations that allow for wormholes or closed time-like curves, exotic geometries that, in principle, facilitate time travel or communication with the future or past. The energy requirements for such phenomena are mind-bogglingly large, leading most to dismiss them as hypothetical. Nevertheless, dreamers wonder, might these new supercolliders approach the energy thresholds needed to nudge reality into forming such distortions? Enter the concept of time gates, a phrase rarely uttered in mainstream academia, but whispered among a few daring theorists. They postulate that if a micro-black hole remains stable even for a fraction of a second longer than expected, it might, in some improbable synergy with quantum fluctuations, seed a region of space-time loop. The effect would be minuscule, maybe subatomic. And yet, the idea hints that signals or particles could traverse that loop, effectively bridging moments in time. In popular culture, we see the result, a swirl of sensational claims about time travelers emerging from labs, or messages from the future gleaned in cryptic data patterns. Serious scientists roll their eyes at the hyperbole, but concede that the boundary between known physics and the unknown can yield surprises. The question is whether those surprises can indeed reorder cause and effect, or remain ephemeral curiosities that vanish in a blink. Critics label the time gate speculation as a prime example of how unverified theory can sow confusion. They point out that each major collider experiment thus far has validated the standard model or discovered new particles consistent with existing frameworks, not triggered cosmic paradoxes. They highlight that no sign of chronological tinkering has ever emerged from high-energy labs. The counterargument, championed by certain fringe voices, is that any time manipulation might operate in subtle ways, or that visitors from the future might hide themselves or manipulate the data to remain undiscovered. That line of thought slides quickly into conspiracy territory, suggesting a clandestine council of future travelers influencing present-day science. Despite the outlandishness, the narrative gains traction among those eager for cosmic mysteries. Amid all these swirling controversies, a new generation of colliders is proposed, each boasting energies an order of magnitude higher than the last. Notably, a rumored facility in a remote mountainous region is said to be in advanced planning stages, bigger and more powerful than the LHC ever was. Official press statements emphasize the pursuit of the next frontier in fundamental physics. But behind that official positivity, some worry that crossing energy thresholds we do not fully understand is a dangerous game. Whispers about an internal design that aims specifically to produce micro-black holes in stable or near-stable form stoke the fires of doomsday talk. Government spokespeople dismiss the rumors as baseless, maintaining that all black hole scenarios remain fleeting, ephemeral, dissolving in a micro-instant. Meanwhile, the time gate enthusiasts double down. If black holes are ephemeral, perhaps ephemeral is enough. A fraction of a microsecond of closed time-like curves might still disrupt local causality. Public debate intensifies when a former member of the design team leaks partial documents hinting at non-public experimental goals for the next collider. The documents contain cryptic references to phase shift detection, tachyonic boundary scanning, and time lensing, fueling speculation that the lab is indeed testing time manipulation theories. The official line is that these references are mathematical placeholders for advanced detection methods and not literal time experiments. Yet the rumor mill spins on, painting images of a shadowy government or corporate interest obsessed with forging a temporal advantage, maybe a military use, or an attempt to glean foreknowledge of future events for profit. The question remains whether such paranoia has any basis, or if it's the same old pattern of doomsday hype that accompanied earlier colliders. At the intersection of all this stand the scientists themselves, some privately intrigued by the notion that new phenomena could indeed manifest, most quite certain that time gates or doomsday black holes remain in the realm of speculation. They conduct their collisions, track data on massive computer clusters, interpret scattering results, and watch for rare signals indicative of new physics. Meanwhile, a handful of them suspect that even if wormholes or time anomalies are theoretically possible, the labyrinth of cosmic censorship and quantum constraints likely forbids them from forming in a stable manner. Nature is subtle, but not malicious, these scientists like to say. She won't let us blow ourselves up easily, nor will she let us casually unravel time. Yet the theoretical possibility lingers, producing an undercurrent of awe or dread. Case in point, a peculiar data anomaly arises in one of the earlier test collisions at a mid-range collider, revealing an unexpectedly symmetrical burst of gamma rays, reminiscent of matter-antimatter collisions, but with an unusual signature. The ephemeral swirl of data lasts nanoseconds, then vanishes. The mainstream interpretation is that this is either an instrumentation error or an undiscovered resonance that might lead to identifying a new heavy boson. But some lab insiders claim the data hints at momentary negative energy states, which certain exotic models link to space-time curvature. None of this is definitive proof of anything like time gates, but the rumor spreads that the door cracked open for a femtosecond. The official lab statement tries to quell sensational talk, while time gate enthusiasts see it as a sign that the boundary between science fiction and fact might be more porous than expected. So we are left at a crossroads. On one side, the meltdown fear that we are building doomsday devices in pursuit of scientific knowledge. On the other, the starry-eyed hope that once we harness black hole creation, we might discover not just new subatomic laws, but also the capacity to glimpse or manipulate the future. That tension reflects the larger struggle within advanced science to push forward the boundaries of the unknown while grappling with deep moral and existential questions. If, in some improbable scenario, these colliders can warp reality enough to disrupt time's arrow, do we even want that power? Or do we risk fracturing the consistency of our own timeline? In the swirling debates, philosophers re-emerge, pointing out how all known experiences confirm the arrow of time. They highlight the paradoxes that would arise if a single scientist could send a message back or forward in time, like the dreaded grandfather paradox. Others retort that quantum mechanics might handle these paradoxes in ways we do not yet grasp. The concept of closed time-like curves might exist, but nature enforces them to be self-consistent, meaning no ability to drastically alter the timeline. Thus, even if time gates exist, maybe they can't rewrite history or break the future. They can only fulfill what is already fated. Such abstract arguments do little to calm the swirling anxiety or wild speculation among the public. Then again, perhaps the entire discussion is a red herring overshadowing the real question. Are these colliders, through fundamental research, risking unknown catastrophes or unlocking wondrous frontiers that might define the next stage of human civilization? The story wouldn't be complete without acknowledging the historical parallels. At each major step in scientific progress, from nuclear fission to gene editing, people have wrestled with doomsday or utopia scenarios. The difference with black hole colliders is that the scale is cosmic. We tamper with energies reminiscent of the Big Bang, or at least a fraction of them, wondering if the resulting ephemeral singularities might replicate cosmic processes. The public's imagination leaps from micro black holes to unstoppable singularities that swallow the Earth, or from ephemeral wormholes to stable time machines. The truth likely lies in a more subtle realm, where ephemeral events might inform us about quantum gravity or unify general relativity with particle physics. That alone is a monumental quest. But the hype around Doomsday or time gates is unlikely to vanish because it captures the tension between curiosity and dread so characteristic of humankind's approach to the unknown. Meanwhile, smaller-scale experiments continue to yield data about possible extra dimensions or signatures of black hole events. Thus far, none have turned up unambiguous evidence of creation of stable black holes or temporal anomalies. But each null result also spurs new designs, chasing higher luminosities, bigger energies, bolder detectors. Funding accumulates or wavers based on public moods, sometimes threatened by anti-collider activists who brandish arguments about existential risk. Government committees debate the cost-benefit, toggling between the desire for scientific leadership and the fear of unleashing unstoppable forces. In quiet corners of the labs, some researchers joke darkly, "If we ever do create a time gate, how do we know it won't have already changed our past?" The joke is half humorous, half disturbing. The logic suggests that if time travel or rewriting had occurred, we'd never know the difference unless anomalies in memory or record surfaced. The swirl of speculation grows. For the lay observer, it's easy to be lost in a haze of theoretical jargon and tabloid scare lines. The question remains, are we truly flirting with cosmic doomsday devices or building potential time gates? Or are we just continuing humanity's tradition of over-dramatizing cutting-edge science? In the end, real colliders produce incremental findings, measuring cross-sections of particle interactions, verifying or refuting bits of advanced theory. The leaps from these data to black hole meltdown or time warp remain dramatic leaps. But that doesn't negate the possibility that reality might harbor some surprises. The deeper we peer into subatomic realms, the more entangled we become with cosmic scale phenomena. In the quantum sense, small scales can replicate aspects of the universe's infancy, including energies that shape the earliest conditions. Perhaps these conditions do carry vestiges of the cosmic strings that hold space-time together, which might momentarily tremble enough to spawn weird gravitational effects. Whether that translates into time-warping events or catastrophic collapses remains unsubstantiated speculation, and yet it is speculation that resonates with primal fascination. What then of our future? If we keep building bigger colliders, we'll keep pushing into unknown territory, deciphering how nature organizes fundamental forces. Along the path, do we risk stepping across a threshold that nature left dormant for eons? Some argue we need an international moratorium until we glean more about the risk. Others press on, claiming knowledge is indispensable, that the potential for a deeper theory of everything, or even discovering intangible phenomena, outweighs intangible fears. Thus, we arrive at a moral crossroad. The drive for knowledge has propelled us from stone tools to nuclear power. Is controlling or risking black hole energies or time anomalies the next rung on that ladder, or a rung that might break under our weight? Given the intangible stakes, perhaps a middle approach emerges. More robust safety committees, open data, and shared accountability among nations. Then, if evidence of doomsday risk or time distortion emerges, we can pivot. That's the plan, at least. In the meantime, the swirl of rumor continues to swirl in corners of the internet, in novels, in the mind of the curious. The next big collider might begin operations next decade. Will we see the same outcry about black holes devouring Earth, or the same hush about covert time experiments? Likely so. The deeper question is whether we can remain collectively rational enough to parse the difference between plausible caution and wild fantasy. Or perhaps the line between them is narrower than we think, shaped by the fundamental weirdness of quantum gravity, which we have yet to unify with cosmic scale phenomena. And so we remain in that tension, living in an era where science can replicate energies from near the dawn of time, but also an era still haunted by primal myths and cosmic anxieties. Doomsday devices or time gates might be the dramatic label pinned to these advanced colliders. The reality is more intricate, blending partial truths from all corners. Yes, black holes might form in ephemeral bursts and vanish harmlessly. Yes, in the outer edges of theory, exotic solutions suggest the possibility of closed time-like curves. But thus far, no doomsday, no time travelers stepping through swirling cosmic vortices with messages from tomorrow. Instead, we see a methodical progression of data, inching us closer to a fundamental understanding of the universe. The question is whether that incremental approach might one day cross an invisible threshold, opening a new epoch we can't anticipate. Some call that the final risk of unstoppable curiosity. Others hail it as the unstoppable impetus of human progress. In the final analysis, these arguments revolve around more than just the technology of colliders or black holes. They highlight the tension between fear of cosmic scale mistakes and the longing to unravel the deepest cosmic riddles. Humanity stands enthralled by the possibility that we could either harness black hole phenomena for breakthroughs or unleash horrors. Are we akin to the mythical figure who steals fire from the gods, uncertain if it will illuminate or destroy? Perhaps, but that metaphor has repeated across centuries of scientific evolution, from splitting the atom to mapping the human genome. Each time, the question remains, do we proceed or shy away? At present, the best we can do is weigh risks with reason, proceed with caution, and keep an open mind to the improbable. The doomsday scenario of black hole creation devouring the Earth is extremely unlikely, say the experts, supported by cosmic ray arguments and rigorous safety reviews. The notion of time gates remains a remote possibility in the labyrinth of advanced physics, but it's not groundless in theory, just highly improbable in practice. The swirl of speculation, though, brings color and intensity to the public imagination, fueling the interest that might, ironically, help secure funding for these colliders in the first place. Eventually, the new colliders will power up, and results will trickle out in academic papers, overshadowed by complicated jargon about cross-sections, squark searches, or gravitational K-factors. The doomsday crowd might hold weekly vigils, waiting for the Earth to vanish. The time gate believers might watch for any anomalies in data that suggest a glitch in causality. Life, presumably, will continue as it has, normal yet spiced by glimpses that reality is more expansive than we can easily conceive. Meanwhile, deep in the ring of magnets and accelerating beams, protons or heavier ions will smash, fleetingly replicating energies from the cosmos' earliest moments. Will that reveal intangible doorways into tomorrow or yesteryear? If so, we might not even detect it. The effect could be ephemeral, or the timeline might self-correct. Alternatively, if the alarmists are correct, we might awaken one day to a catastrophic horizon swallowing everything. The extremes remain hypothetical. Hence we stand. Doomsday devices or time gates remains a rhetorical question, pointing to how frontiers of knowledge can blur into mythic dread. For those enthralled by science, it's a testament to the wonder that we can even ask such questions seriously. For those seeking to preserve safety, it's a clarion call to keep a close watch on every step. Each new experiment is another step on a cosmic high-wire act. The only certainty is that as long as curiosity drives us forward, we shall keep building bigger colliders, keep chasing hidden aspects of the universe, keep grappling with moral ramifications. In the end, the potential for black holes or quantum anomalies remains overshadowed by our collective thirst to know. Perhaps the real fear is not that we might destroy ourselves or open a rift in time, but that we might discover a vastness that humbles us beyond measure. forcing us to reevaluate our place in the cosmic tapestry. And in that sense, maybe it's not fear we should feel, but awe. If a doomsday or time gate scenario lingers on the horizon, let that be a reminder of how truly extraordinary our quest has become. And if we pass the threshold safely, discovering new laws or bridging the chasms of theory, we might look back on these decades of speculation as the time we hovered between darkness and brilliance, uncertain of whether we were forging our doom or our destiny.